Hello, welcome back to Cracking the Cryptic on Saturday evening, and I'm going to be having a go at a puzzle by Bremster today. It's been recommended not just by Bremster but by others. It's called Ironworks, and it's a mix between killer and quadruple Sudoku. Now, earlier today, I had a go at this current round of the Sudoku Grand Prix. It runs over the weekend. It will go into Monday. All you have to do is look up Sudoku Grand Prix in Google and register if you haven't already with the World Puzzle Federation, and you can take the test. You get 90 minutes. There's, I think, 13 puzzles. I'm normally reporting my attempts at these with a hangdog. Oh, it didn't go very well. Today it went, I thought, very well. I got 12 of the 13 puzzles done in the 90 minutes, and I was very pleased with that. Irritatingly, 10 seconds after the time was up, I noticed that I'd transposed 2 digits in one of the more valuable classic Sudoku answer strings, so I won't get credit for that. But it was very good fun, and I do recommend it. They are pretty approachable puzzles. Simon did an example puzzle of 5 is Still Alive by Sed Holesen lately, and there's a very good 5 is Alive puzzle in that set as well. So check it out if you're interested in solving against the clock. Now, Simon also wants me to check his video tonight, which I'll be doing as soon as I finish recording this. He's going out to a pub quiz, apparently. I'm really hoping he gets recognized, because that should put the fear of God into somebody at the pub. We'll see. I don't know. I'll be interested to hear how he got on. Yeah, after he's recovered from the shock of losing a tree during the storm and while he was shooting his video. That's astonishing. I loved the comment from somebody who said, "Simon, let's get cracking. Tree, okay." And then it's just gone. That was really clever. Right, now there is still 1 day left to enter our Patreon competition. So 4 p.m. tomorrow is the deadline, our time. Do get your answer in by then. You still have time to start and finish it, because it's quite approachable Sudoku. You still have time to join Patreon, download the quiz, download the Sudoku hunt, and start and finish it if you want. But you're probably pushing it if you have a go at the Grand Prix Sudoku and that all by 4 p.m. tomorrow and this puzzle. But this is the first link. Before all the links about the merchandise, which has been selling very well, the apps and the Sudoku Pad and Patreon and Discord, this puzzle is linked, and it's called Ironworks by Bremster. Normal Sudoku rules apply. Digits in cages must sum to the number in the top left corner of the cage, so normal killer rules there. Digits cannot repeat within a cage. Normal enough again. Digits in circles must appear at least once in the 4 cells touching that circle. So we must have a 5 and a 6 in this group of cells. We must have at least 1, 2, at least 1, 3 in that group of cells. Do give it a go. I'm sure Bremster's puzzles are always great fun and very much worth the challenge. So maybe check my video time. Yes, I had a pretty decent guess at my video length yesterday. I was a few percent out. I guessed 45 minutes and I think it was 52. Today, I am not going to do this every time, but I'm going to guess 30 minutes. No idea. We shall see. Do give it a try. Let's get cracking. Okay, so yeah, we've got this big cage in the middle with no number in it, but we don't need the number because we know the secret. If that's got to be all different digits, there are 9 cells in this eye-shaped cage, and the 9 cells must be the numbers from 1 to 9, because they can't repeat. And you and I know, don't we, that they add up to 45 every time. So we don't need the cage total for that. Right, where do we start? This is not one of those puzzles, I think, where you add up. Even if you added up these numbers, I'm just going to, just to prove it. 28, 39... 5166. Now, because we know the first 2 columns must add up to twice the secret, so 90, that tells us that those 4 cells add up to 24, but that's not very useful. And the same this side. These are all very middling numbers. It's not really going to do anything useful. So never mind about that. Yeah, I think it's to do with these quads. We've got 1, 2. It must be very hard to fit the numbers 1, 2, 3 into this cage and this box and still fulfill all of these things. It doesn't look easy. See, what would be... I don't know. They're slightly odd. These aren't exactly mirror symmetrical. There's 2, 2, 3 quadruple circles. What does it mean? Sorry, I'm trying to figure this out. I'm sure this is something useful. Oh, okay. Yes, here's a thought. This applies to every number 1, 2, and 3. If that... Oh, that's lovely. If this was a 1, this wouldn't... Oh, no, that would work. Okay. I was thinking that would put a 1... Yes, if this wasn't a 1, then we'd have a 1 in one of these 3 cells, and that would be in the cage. So we couldn't have a 1 there, and we'd have to have a 1 here. Oh, so one of those is a 1. Is that right? If this one isn't a 1... There's a 1 in the cage there, so it can't be in the cage here and has to be there. So if that's not a 1, there's a 1 there. And those are therefore the positions of 1 in the box. Is that... That's going to work for 3 as well, isn't it? And I'm a bit confused now. If this isn't a 3, there's a 3 there. Oh, that's impossible. If that's not a 3... There's a 3 there, and then there can't be a 3 anywhere here, and to fulfill these 2 3s, we'd have to have 3s both there. What? Does that mean this is a 3? Yeah, I've proved that that can't not be a 3, so that is a 3. Now there isn't a 3 here. The 3 on this 1, 3 is in one of these 2 cells. Well, it's not there. That's in the same box. So it's there, and that works for this 3 too. Now this has got to work for 2 as well, because it appears in 3 cells. So I think it means if there wasn't a 2 here, there'd be a 2 in one of those 2 cells, and then you're never going to get a 2 around this, because the cage has already had its 2. That's brilliant. So there's a 2 there. The 2 in the cage now has to be here to help both of those clues work. Yeah. And all of these cells are seen by that too. So look, we've got 2s there, 3s there. Ah, 1. Yeah, these 3 cells can't be a 1 because 1 is in one of those 2. So the 1 in the cage... Oh, I see. If that's a 1, the 1 in the cage is going to have to be here to help this 1, 3 work. But if that's a 1, the 1 in the cage is going to have to be here. So that's sort of that 1 is in one of those 2 positions and one of those 2, but in only one case is it in, and in exactly one case, is it in box 5. That's such a strange set of relationships. That's really interesting. Now, the last one, the 1 in column 5, is going to have to either be there or there, and that's going to kind of determine which of these pairs of 1s, how they resolve. But I don't think 18 and 21 are cage totals high enough to help us determine which one has the 1. 3 has to be in one of those 2 cells. It can't be there because we've got the 3 in the cage. 2, I suppose, is the same. Goes in one of those 2. It can't be there because we've got the 2 in the cage. Again, they're not all that helpful. Okay, what do we do next? I don't think these do much else. Look at all these weird little 15 cages in symmetrical positions there. They're strange. And these 11s. Okay, let's use the secret. This box adds up to 45. These 2 cages add up to 38. that means, oh look, that's nice. That means that those two minus that equals 7. Now that's a slightly complicated deduction, but I think it's going to be helpful, and here's why. Those two add up to 38. That set adds up to 45. The difference is 7, and that's made up by those two, which contribute to the 45, minus that, which contributes to 38. I'm just checking. So that's the case. Now, the interesting thing about this is, where does this cell go? Whatever digit is in this cell, let's call it a 0 for now. Where does it go in box 4 here? Because it can't go in this cage and it can't go in those two cells. So it is in one of those two cells. And what's really interesting about that is we know the difference between those two cells and that one is 7. And obviously that digit is replicated in one of these two cells. So the other one is a 7. So let's put a 7 in one of those. Get rid of 0. That was just a placeholder to show what I'm talking about. One of these is a 7. Oh, and obviously it's around the 7, 8. It's not here because the 7 in the box is around this 7, 8 quadruple. So we get a 7. That's very elegant too. Now, what does that do this side? These add up to 36. So those two minus that is the difference between 45 and 36 equals 9. And this, again, appears in one of those two cells, because that's where it has to be in the box. So the other one of those is a 9. It's exactly the same as over here. Actually, let's do a little bit of odd colouring as well. I'm going to make that orange. That is the same as one of these two. So it's either 7 or whatever appears down here. And this is the same as one of these two. No, it's different here. It's different here because 16, 27, this can't be 9. It's the other digit. But this can be 7. Why is that different? Am I right? Am I getting confused? I must be getting confused because these ought to be perfectly symmetrical. 36 there means that those two minus that equals 9. But one of these is 9. So the other one is the same as that. Whatever one isn't 9, this can't be a 9, I don't think. That's really strange, but I think that's true. Whereas I think this can still be 7, or have I got that wrong? 38, no, 45. 7 is the difference. That is the same as that. So this is the orange cell. I think that's right. This can't be a 7, can it? That is the same as that, yes. And blue is the same as not 9 here. Wow, that's really weird. Oh! One of these 15 cages has got a 9 in. And if it was up here, that would have to be a 1, 5, and that would fix the 1s. Ah, but I don't know what the other one is. What next then? Ah, this 7. No, this is brilliant with the 9s. Right. One of those has a 9 in. Yes. No, I was going to say, so one of these is a 1-5 pair, but that's not necessarily true. Because if that one has a 9 in, then this is a 1-5 pair, and that fixes the 1s there, and then we can't have any 1s over the rest. But now I'm thinking, if that's got a 9 in, this could be a 2-4 pair. So then this could still be 1. What I was hoping to do was to rule 1 out of here, because this is a pair that makes 8 to make up the 15 sum, and it's not 2, 6. If I could have ruled out, oh, well, it's obviously not 1, 7, because there's a 7 there. I'm going mad. That is 3, 5. Ah, And this can't be 9 now. That's perfect. This can't be 9 because this pair would have to add up to 6. And it can't be 5, 1 because of that pair, and it can't be 2, 4 because of that. So this is not 9. This is blue instead. Because 9 and blue are mutually exclusive for a moment here. And this one is 9. These two do add up to 15, but I don't know whether they're 1, 5 or 2, 4. Right, this is an intriguing puzzle. Now, what else has that taught me? I'll tell you what, 7 and 8 have to go in this 2 by 2. So one of them has to be in this 11 cage and the other one sits there. The 11 cage is either 3, 8 or 4, 7. Doesn't have a 5 or a 6 in it, so 5 and 6 are up here. Blue is 5 or 6. Blue can't be the same as orange, so that's in one of these two cells, but it has to be on the 5 and 6, so it's there. Now you can't put 5 or 6 in those cells because the other one of 5 or 6 would have to go in with them, so the other one is there. Orange is 5 or 6. That's brilliant. This is orange as well, for what it's worth. Oh, that's so clever. Right. Now, what about this? It can't be 5, 6 or 7, 4. So it's 2, 9 or 3, 8. Now, I'm just starting to wonder about these 5 rows and whether I can total them up. And maybe I should have thought about that before, but I've made some progress. Yeah, this is quite interesting. First of all, I'm going to highlight the cells that are not in cages here. I think it's those ones. Now I know the totals of the cages. Right, over this side we have 27, 38 and 2 15s. That's 68. Right, I'm just going to note these down up here. These are not Sudoku numbers, this is just totaling. 68 on the left side, 45 here, and a 2 and a 3 and a 1 in one of those cells. So if I count all of those as well, that's 51. On the right side, 36 there, 2 15s, that's 66. Right, I'm going to add those 3 up. 15, 185. That's not very good writing. 185, let's get rid of those numbers. Now the total of all 5 rows is 225, which is the secret times 5. 45 times 5 is 225. Now I'm just going to check the maths because I don't want to make a mistake with this. We had 66, 45, 38, 68. Oh, but I was also adding 3, 2 and 1. Yes. So I've got a difference of 40. Now that difference represents the yellow cells, but not including 3 and 2, or the 1, which appears in one of those. So these other 5 cells, I don't know which one in the middle, but the other 5 cells have to add up to 40. That's quite a big number. If these two were 9, 8 pairs, then the other one that's not a 1 is at least 6. And I don't have many degrees of freedom. I've got 3 degrees of freedom. So these can't come down below 5. They're from 9, 8, 7, 6, 5. These ones are either 1 or again. No, not 5 this time. 6, 7, 8 or 9 in there. That one can't be a 9 because of that. And that's quite, look, that's quite pretty. Let's get rid of the 40. I'm going to try and remember this total of 40 because I'm probably going to need it at some point. But look at this middle box. Where's 4? It's not in any of those cells. It's too small to be in a yellow cell that isn't a 1. So it must be in one of these 3 cells. Now it's not in those cells because it's already in the cage somewhere. And therefore, where's 4 in this row? Not in those cells, it's over here. Isn't that beautiful? And that means this is a 4, 5, 6 cage to make 15. That's extraordinary, actually. Oh, look, there's no 5 in that row because of the 3, 5 pair. So that's a 4, 6 pair. Blue becomes 5. How about that? Orange becomes 6. Oh, that's a blue 5 as well. There's not much point keeping the colouring going, but it fixes 4 and 6 up there. That can't be a 5. This can't be a 4. Wow, this is such an interesting puzzle. These can't be 5 or 6 anymore. 6, 5, 3, 2, 4. This pair has to add up to 9, and it's not 6, 3. Actually, it's not 5, 4 either, because one of those will be in one of these. So it is either 2, 7 that way round, or a 1, 8 pair. Oh, have I not? Oh, look, there's got to be a 1 in this group of 3. And we know that that's not here because there's a 1 pair down there. So we've fixed these central ones. That's not a 1 now. This one is the central one. I'm going to uncolour it because I can now use that these yellows add up to 40 perhaps. Well, I mean, I can't yet, but maybe. Now I can at least memorise that the yellows add up to 40. I've got the one in the eye shape. 3, 5, 1, 2. That is 7, 8 or 9 by Sudoku. Now that's not a 1. So where's 1 in this row? Not sure. Could be either end of it. 5, 6. Do I not know what these are? Apparently not. 1 and 2 in this. Oh, 1 and 2 in this cage are a pair there now. 1, 2, 6, 5. So this is the other of 3, 4 or 7, 8. In fact, that pair add up to 11 because they're the opposites of those two, which can't be in that order at least now. If they add up to 11, they're either 3, 8 or 7, 4. That's a pair that adds up to 11 as well. This can't be 4 because that would have to be 7. So that's not 4 anymore. If they are 4, 7, they're that way round. If they're 8, 3, they're that way round. That can't be a 6. Couldn't have been for a little while now. Oh, this is just weirdly interesting. Now this is a 6. No, that's always been the case. These add up to 9. Those add up to 6. That's 15. Oh, where does 5 go in this eye shape? Yeah, there's only one place left. There it is. That's going to put a 5 in the 18 cage at the top. What have we got left to put in? We need a 6 in this cage as well. That's fixed as well. That's there. The 5 has made this a 2, 4. That makes this a 1, 8 that I don't know the order of. And these are now a 7, 9 pair. Right, now can I use the fact of the yellows adding up to 40? 16 there. These have to add up to 24. Those two will be different because they're in the same row. And I think that means they have to be a 7, 8, 9 triple between them. In fact, this isn't 7 because I've got a 7 there. I think this means this is a 7, 8, 9 triple, but I'm not. Well, the 7 in this cage is clearly in one of these two cells, so that's not a 7. So that was the only conclusion I was going to reach anyway from this being a 7, 8, 9 triple, which I think is right, but I'm not risking doing anything with it. Now, it's odd that I haven't. There's an 8 got to be around here. Can that be an 8 if this was a 2, 9 pair? Yes, it can. I'd forgotten the quadruples. I thought I'd dealt with them all, but maybe I haven't yet. Oh, I tell you what, this 13 cage can't have a 1 in it. That feels interesting. So what are the possibilities? 2, 3, 8 is not, because it can't have an 8. So 2, 4, 7. 2, 5, 6. Or 3, 4, 6. Well, they've all got a 6 or a 7 in, which would have to be in that cell because it can't be here. And these would be from, I don't know, that doesn't feel quite as fruit. Oh, look, that 5 is fixing a 3 up here. Ah, well, that's getting better. Now there's not a 5 in it. Ah, which of the possibilities had a 5 in? So it was 2, 4, 7, or 3, 4, 6. So there's definitely a 4 here. Now, this can't have a 5 or a 3 in it. Is that useful? Don't think so. There's still quite a few possibilities, including 2, 4, 6. Actually, 2, 4, 6 isn't possible now, because 6 would be there and 4 would be here, which would clash with the 4 down here. Right, if 2, 4, 6 isn't possible, this must have a 1 in it. Because it can't be 2, 3, 7 because of that, yeah. Oh, 3, 4, 5, no, it can't be that. Okay, it's got a 1 in it, definitely. And it's either 1, 2, 9 or 1, 4, 7. Seven can't be there. 4 can't be there. Ah, so it's definitely 1, 2, 9. Is that right? I think that's right. Because of the 4 being fixed here, this has to be a 1, 2, 9 cage. I think that is a perfectly valid conclusion. Although I have to admit, if I go wrong at some point, I might come back and revisit that. But I think that's right. 3 can come out of there, 9 out of there. Now, what's going on up this column? I don't know, actually. I thought that was going to resolve the 11 cage. But I don't think it has. Curses. Now, 4, 6, 7, 8 still to go in. Oh, what about this cage? 18, and we can't have 1 or 2. 3, 4, 5, 6. It has to be. So 3 is there. Oh gosh, I should have looked at that a while ago. 4 is there. This is a 5, 6 pair. These are from 7, 8, and 9. Now, 5, 6 there. 2, 3, 1 has to be in this 21 cage. 4 and 7 are there. So these digits are from 1, 8, and 9, which is probably not all that surprising. Is the 2 going to be in the cage or not? 9, 8, 2, 1 would only be 20. So no, it's not. If you had 1 in the cage and 2, you'd need another 18. That's not possible. So the 2 is outside that cage. And that's not a 2. Did this box need a 2? No, it could be 3, 4, 6. Right, but we must know what this digit is because these add up to 5, 10, 16, plus 21 is 37. That must be an 8. That means this is a 1, 9 pair. This is going to resolve lots of things, including putting a 9 there. Therefore, the 9 in the I cage is there. That's an 8, 7 pair. These do add up to 40, definitely, so that has been proven right. That is 4 or 8. This is 4, 7 or 8. Is that going to determine? Not quite. Maybe it does, I don't know. 4 and 7 are done down there. That can't be 4, but we need a 4 in this cage. So it's there. This can't be 7 now. That's a 3. That can't be 3. Oh, now I've got something wrong in this cage. Let's go back to 2, 3, 8, 9. This one can't be a 3. Nor can this. Oh, right. So it is a 2, 9 cage now. That's fine. 1, 2, 9. That's an 8. 2, 9 there makes that a 1. 6, 5. Oh, it still doesn't resolve everything. 7, 2, 9, 6, 5. 3 is in one of those cells. Oh, why is it not giving up? Oh, this 12 cage can't have a 2 or a 4. Is it 138 or 156? It's not 156 because 6 can't go in it. So it's 138. Yeah, we can do all that. 3, well, we can do the 3, and the 1-8 resolves this 9-1 pair. 5 and 2 along the bottom are done. 6 has to be there. Still a 7-9 pair. This can't be 3 or 4. Right, so that cage is resolved. The whole of box 6, the whole of box 5. I want to say the whole of box 4, but it probably won't quite all be done. Oh, very nearly. 1-8 there. Right, that has become a 1 in the column. We've got 2 and 7 up here, which makes 9. That's a 5. That fixes 6 and 5. These can't be 9s. That fixes 2 and 7. Ah, this is a lovely puzzle. This is so elegantly put together. 5, 7, 1, 2. That's 8 because it can't be 1, 2, or 9, which are in the cage or in the box already. That fixes these yellows finally, which has taken quite a while. 7, 9, 7 and 5 down there. No, something's wrong. No, maybe not. 5, 5, 5. No, not necessarily, thank goodness. 6, 4, that can't be 2. 1 in this box goes there. 9 and 3 are resolved. 9's there. 1, 2 pair, 9. 2 and 9. It looks like my half-hour guess is not too far off the mark again this time. I must keep this going. 2 and 1 to finish. There we go. That is a very clever puzzle. There's a lot to unpack in that. Very interesting. Ironworks by Bremster. An excellent puzzle from Down Under. Let's just get rid of the colouring, which I think the yellow was useful, but I'm not sure. Yeah, no, the blue stuff was. I'm not sure I fully understood what I was doing. I had more available from the blue and orange colouring earlier on than I was using. But that's a really interesting puzzle. Thank you very much, as always, for following us on the channel, and hope to see you again soon for more Sudoku. Bye for now.